Good evening, friends. We are continuing our lecture 8, chapter 1, class 11, maths sets. So, now today we are going to discuss the practical problem and union intersection of two sets. Okay. So, what is the practical problem? Practical problem is such that set A and set B has some common elements and they might have not some common element. So, what are the basic formulas for finding union, intersection and other countings of elements? Okay, so let A and B be two finite sets such that A intersection B is phi. So I am drawing the Venn diagram for case first. Let A and B are two sets and they have no common element. No common element means they do not intersect each other. The Venn diagram of two circles will not intersect each other, so we get no element here. This is set A and this is set B. If you want to find the number of elements in A union B, then you will get number of element in A plus number of element in B. The first case can be very generalized, written as follows: the number of element in A union B is the number of element of A, number of element of A, then number of element in B, and while we add these two, as you guys can see that we has twice counted the center region. So what we have to do is we have to just subtract this inside portion once. So we just subtracted it once. So this is the general formula in case of two sets, and number of element in A union B is equals to number of element in A plus number of element in B minus number of elements in A intersection B. For the third case is a example of three cases. What are the three cases? Here is the three cases. Here is set A, set B and set C. If I will draw a Venn diagram for the case third, what we will have? We have set A, we have set B and we have set C. This is set A, this is set B, this is set C. So if you want to find the number of element in A union B union C, what you will have to do? You will have to add number of element in A. I will diagrammatically try to visualize you guys that number of element in A, then number of element in B. So how to find out the number of element in B? Number of element in B, as you see that we had twice counted this region. So what we will do, we will subtract this first portion which is the intersection of A and B. So we will subtract the intersection of A and B and then we will add the number of element in C, because the C portion is yet not covered. So we will add the number of element in C. So for adding this number, as you guys can see, when we add this number of element in C, we actually add this portion and we actually add this portion also. The first portion which is on B and C side is the intersection of B and C, so we subtract the intersection of B and C, and the second part of C which is the common of set A and set C, so this is the another portion which is intersection of A and C, so we will again subtract this A and C part. But by doing this we actually remove the center portion which has to come from these all sets. So finally, since we have not yet counted the center portion, so we will add the center portion as number of element in A intersection B intersection C. So either you mug up these two general formulas to solve the practical problem coming up here. Now we are going to implement those earlier formula which we just read by the help of also drawing the Venn diagram. Okay, so first question is that x and y are two sets such that x union y has 50 element. Okay, x union y has 50 elements and x has 28 element, y has 32 element. So how many elements do they have in x intersection y? Okay, so we will going by the formula that number of element in x in union y is the number of element in x plus number of element in y subtracting number of element in x intersection y. Putting the values here, right? Union has 50 elements, x has 28 and that has 32 elements, and negative of x intersection y. So by sending this portion to another side of is equals to, we get number of element in x intersection y as 28 plus 32 is 260, and by bringing this 50 to this side we actually have 50 negative sign, so we get number of element in x intersection y as 10. So that's how we just solve our first question, which is number of element in x intersection y. X intersection y has 10 elements. Coming to, this is the very first example we just solved right now. Now we are going to solve the second example in the same case. In a school there are 20 teachers who teach us mathematics or physics. Of these, 12 teachers of maths, 4 teachers and 4 teachers teach both physics and mathematics. How many teachers teaches physics? Okay, so we have here maths and physics. So 12 teachers teaches maths. 12 teachers teaches maths, and how many teachers teaches physics? The number of physics teachers has to be known, and 4 teachers teaches both mathematics and physics. So mathematics and physics is taught by 4 teachers, and the school has only 20 teachers. The number of maths union physics is 20. So now we will try to put this all the data in the formula. Maths union physics is equals to number of elements in maths plus number of teachers in physics, negative of number of elements in maths and physics. We will put all the data. 20 is equals to 12 plus number of teachers of physics, negative of 4. So 20 is equals to 12 negative 4 is 8 plus n number of physics. So number of physics, we will send this 8 to that side. Number of teachers of physics we will get as 20 minus negative of 8, which is 12. 12 teachers in the school. There are 12 teachers who can teach physics. Coming to example number 3, in a class of 35 students, 24 like to play cricket, 16 like to play football. Also each students like to play at least 2 games. How many students like to play both cricket and football? Okay, so there are how many games? There are 2 games. Okay. Number of students who like to play cricket is 24, and 16 like to play football. Football is liked by 16 students, and in a class 35 students are there, and student has to like at least one of two games, means the intersection, that we will have to use this data as union. Cricket union football is 35 students. So now they are asking how many students are there in the class who likes to play both cricket and football. Both means we will have to find intersection of these two games. We will use our traditional formula which I just recently taught you, that number of elements and number of students in cricket union football is equal to number of students in cricket plus number of students in football negative of number of students in cricket intersection football. So we will put all the data. Union has 35 students and they have 24, then they have 16 and they have no, we didn't know this intersection part yet. So 35 is equals to, we will add this 6 4 10 0 1 1 2 3 4. So actually there are total of how many students, then we will send this negative to that side, so it will become positive. Number of students in cricket and football is equals to 40 negative of 35. We will send this 35 to that side, so it will change this sign. So there are only 5 students who likes to play football and cricket. Coming to our example number 4 of this session. In a survey 400 students in a school, 100 were listed to taking apples. Okay. Number of students who are taking apple juice is 100. Number of students who are taking orange juice is 150, and number of students who are taking both apples as well as orange juice. Okay, so both apple and orange juice are 75. That means apple and orange juice is 75. And they are asking how many students were neither taking apple or not taking orange juice. So we will, with the help of all three datas, we can find the union of A and U, means how many people are. We will have to find A union O, means students who are taking either apple or orange juice by this formula, and apple plus number of orange juice students taking negative of number of apple intersection orange. So there it is 100 and 100 plus 150 negative of 75. So it is 250 negative 75. 250 negative 75 is how much? 175. So in the school there are just 175 students who are either taking apple juice or orange juice, but the school has 400 students. So number of students who are not taking orange, neither taking juice, is the 400 negative 175, which is equals to 225 students are neither taking apple nor taking orange juices. Coming to example number 5. In this example there are 200 individuals with a skin disorder. Okay. 120 exposed to chemical 1. This number of patients who are exposed to chemical 1 is 120. Number of students, number of individuals who has been skin disorder due to exposed to chemical 2 is 50, and 30 are the which is exposed to both chemical 1 and chemical 2. To find the number of individuals exposed to chemical 1 but not chemical 2, chemical 2 but not chemical 1, and chemical 1 or chemical 2. Okay, we will definitely find it. We also have 2140. Actually there are 200 individuals, so chemical 1 or chemical 2. Okay, let's see. If we try to find out the solution of this case with the help of the Venn diagram, what we will have to do, we will draw a Venn diagram and draw two large circles, naming them chemical 1 and chemical 2. So the number of, firstly we will have to fill up this area, this the intersection area. So this is the number of patients of which are exposed to chemical 1 and chemical 2 is actually 30. So if I remove 30 from chemical 2, how much we left? We left 20. So we write here 20. If we remove this 30 from this side, how much we left? We left 90. So I write 90 here. Okay, you got my point? Now coming to answer, coming to give their answer to part 1, they are saying chemical 1 but not chemical 2. So chemical 1 but not chemical 2 is which portion here? This portion is chemical 1, but not chemical 2. So how many patients are there actually here? Okay, so chemical C1 but not C2 is actually 90. Okay, got it? 90 is the answer here. And they are saying chemical 2 but not chemical 1. Okay, so now they are saying that we will have to mark chemical 2 not chemical 1. So this is the area, or this is the number of patients who are exposed to chemical 2 but not chemical 1. Chemical C2 but not C1 is actually 20 patients. Now in the third part they are saying patients which are exposed to chemical 1 or chemical 2. If they are asking this question, then what you will have to mark up? They are saying or means actually union. So they are actually asking us all the number of patients who are actually subjected to any C1 or C2 chemical. So what we will do, we will just add these all three datas here: 0, 11, 12, 13, 14. So actually there are 140 patients who are subjected to, all who are expected to subjected from C1 or C2. Okay, so here we get 140 and here we get only 20. So that's all for today guys. Thanks for watching and see you in the next video, in the next video.